Okay, so today we'll solve GATE 2022 questions. So this is a question from complex analysis. This is question number 28. So it is saying that the radius of, you have to find the radius of convergence of the following. This is a power series given. So you have to just find the radius of convergence. Okay, so in order to solving this is the NPTEL reference. Okay, so let's try to solve this one. So what the series is given, n bigger than 0, 3 to the power n plus 1, z to the power 2n, but z belongs to complex number. You have to find the, so this is given, to find the radius of convergence. So let's first first see there is some formula for radius of convergence and what is radius of convergence. Let fz equals to, so this is a general form of power series Cn z minus a whole to the power n for n equals to 0 to infinity. So this is a power series where z is a complex number, Cn are complex numbers also, and a is some complex number. So it is called the power series centered at a. So the radius of convergence, R is a non-negative real number, or it may be infinity, such that the series converges if mod z minus a is less than r and diverges if mod z minus a is bigger than r. So this is called, then this r is called the radius of convergence. Okay, so inside the radius of convergence the series will converge, and the formula for and r, and this r we can compute it in terms of, there is some nice formula. So from here we can compute the easily the radius of convergence of a power series. Then we can find the radius of convergence by the following formula. So what is the formula for radius of convergence? Then r is given by 1 by lim sup of mod Cn to the power 1 by n. So this is the formula for radius of convergence. We will use this one to find the radius of convergence of the series. So for that, notice that we have to write in terms of z. So this is center here, z, for our case center is basically 0. We have to write in terms of zn and the corresponding coefficient we have to find. Now we have n bigger than 0, 3 to the power n plus 1, z to the power 2n. So here center is 0, it's fine, but notice that here it is z to the power 2n. So you have to write, it is not in this form, right? So you cannot directly apply this formula. You have to reduce it into in this form, then only we can apply this formula. So we'll reduce this to that form. So how you will reduce? Put in some 2n equals to k. Then what will happen? If you put 2n equals to k, then it will become n. So 2k is bigger than 0. 3 to the power. So n equals to k by 2. It is k by 2 plus 1 z to the power k. So this you can write also. And note that here k is even also. So 2n equals to k means k should be even. Right. So this you can, let me again write it in terms of n, because k is dummy variable, you can write anything. So k bigger than 0. This is same as k bigger than or n bigger than 0. N should be even. 3 to the power n by 2 plus 1 z to the power n. So let denote it by something Cn z to the power n. Then what is Cn? Where Cn, what is Cn? Cn is 3 to the power n by 2 plus 1 when n is even, and 0 when n is odd. Right. So this is our sequence. So you have to find this lim sup of this sequence. Right. So what is this? Note that this sequence, it has two convergent subsequence. It is not basically convergent sequence. It has two convergent subsequence. So here the note that in the formula it is lim sup. So you have to find the subsequential limit which is maximum or supremum, right? So let's find. Then lim sup of n tends to infinity Cn to the power 1 by n. So this is same as, because 3 to the power n plus 1, this is a positive number, so one sequence will goes to 0 and other sequence, so lim sup is the bigger limit, so it will be same as limit n tends to infinity of this, right? 3 to the power n by 2 plus 1, so this is positive whole to the power 1 by n, right? Because this is the, because other sequence will goes to 0 and this will be the bigger limit will be. So this is same as the lim sup and same is the limit of this sequence. And what is the limit of this sequence? So limit n tends to infinity 3 to the power 1 by 2 plus 1 by n. So limit is basically root 3. So therefore the radius of convergence R, which is 1 by this lim sup, which is 1 by root 3, right? So what, no, so this is the radius of convergence. So what you have to find? Or you have to find it in the round of 2 decimal places. So if you write down it, you can see that this is, you can write it into 0.57 or 58. Round of 2 decimal places. So what we have got? The answer is 0.58. So the radius of convergence of this series is 0.58. Round up 2 decimal places. Okay.